Hi everyone! In this video we are going to discuss pH, or the pH scale. And all the pH scale is numerical values that have been assigned to everything. So every acid, every base, every neutral component, just as a way to indicate how acidic or how basic something is. So if something is a really strong base, it's going to have a lot of their OH minus concentration, or a lot of that hydroxide concentration present in that beaker, in that solution, which means it's going to have a really high value for pH. Now, if we're talking about a strong acid, that means there's going to be a lot of that hydronium ion present, or that H plus or H3O plus ion present in your solution, which means you're going to have a very low pH. So let's write all of that down to make sure that you got every single piece of it. So first things first, let's start off with a definition. So in a very simple definition for pH, we say that we have a number, usually 0 to 14. The standard scale is 0 to 14, but we have discovered some acids that actually have a scale that are negative, or values that are negative. But for us, 0 to 14 is fine. So a number that indicates the acidity or basicity of a solution. Okay, so I'm going to write out a very simple pH scale here for you. And so this is going to be pH. We're going to start off very low. So let's just do 0, 3, 7, 10, and 14. So these are your numbers, all right? So on our scale from 0 to 13. So if you're at a really low pH, we're talking about a strong acid. Right here in the middle, around 7, we're talking about neutral components or neutral compounds. And then at the very end at 14, we're talking about very strong bases, which means there's a lot of that OH minus concentration present. And for the acid, it means there's a lot of that H plus acid concentration. So now, what we have to do is come up with a couple different things that I want you to just know or be aware of where they lay on this pH scale. The first one is lemon juice. We experience this fairly frequently here as humans here on Earth. We experience lemon juice. Lemons have a lot of citric acid. That's a very acidic component, and so it has a pH lower than 3. Right after lemon juice comes soda. In soda, there's a lot of phosphoric acid, and so that's a fairly strong acid as well. So that has a pH of very low. It's much lower than 3. Now, we talked about milk before. Everyone thinks milk is a base. I don't know why people think this. I'm sure it has something to do with what you learned in kindergarten or something, but milk is not a base. It's actually slightly acidic. It's very close to being neutral, but it's not neutral. It's slightly acidic. It is definitely more basic than lemon juice or more basic than soda, but it is not a base. Okay, it's not a base. Now, water is going to be right here at 7. Pure water is right at 7. Right after that is our blood. We have slightly basic blood. Not very much, but it's slightly basic, and that just kind of helps everything circulate, but we kind of already talked about it in our nutrition unit. And then the last thing I want to put up here is ammonia. So we know ammonia is common in a lot of different common household cleaning supplies. And so when you're using ammonia, you need to be very much aware that you are using something that is very basic. So when you're using cleaning supplies, especially harsh cleaning supplies, be careful. Take care of your body. Wear gloves, wear nice gloves, invest in that. You want to make sure you're being okay. Don't dump cleaning supplies on your body, and definitely don't ingest them. I don't know why people do that, but some people do. It's not a smart decision. All right, so let's review what I just said there. If you have a pH that is less than 7, you are talking about an acid. If you have a pH that is equal to 7, you are talking about something that is neutral. Okay, and now if you have a pH that is greater than 7, you are talking about something that is a base. All right, this is your very generic scale. You 100% have to know this. If you don't know this, then it's just a problem. So make sure you get that down. All right, so now, what do we use this information for? Why do we actually care about pH? Well, we've actually figured out a formula where we can use pH and basically back calculate and figure out how much of our hydronium ion or how much of our hydroxide ion we have present in our solution, which is awesome. I think that's so cool. So what we need to realize is that our pH is always proportionate to our H plus concentration. So once we figured this out, that they were directly related, we actually are able to come up with this fantastic, beautiful equation. And so for this course, this is the main one that I want you to know. So pH is equal to negative log of your H plus concentration. So what we're doing right now is introducing two things. Log, which hopefully is a mathematical expression that you're used to. But the second thing is you need to realize that if you do not have a calculator that has a log function on it, you're not going to perform well on this exam or this test. You need to make sure your calculator has a log function, okay? Now, using this equation, let's see if we can calculate some really neat information. First things first, if I tell you that you have a solution that has a hydronium concentration of 1 times 10 to the negative 4th molar, what is the pH? Go. All right, did you get an answer? Hopefully you did. All you had to do was use the equation I just provided for you. So we say pH is equal to the negative log of your hydronium concentration, which is 1 times 10 to the negative 4th molar. Now what's really awesome about this log function is that when you do the negative log of something like this, your answer is simply 4. So it's just whatever that superscript is right there, or whatever your exponent is. So what is the pH of this solution? It is 4, which definitely means you're talking about an acidic solution. Now, I'm going to throw a curveball at you. You're going to have to remember information from the previous video here. Now, if I tell you your OH concentration, your hydroxide concentration is 1 times 10 to the negative 4th molar. Now, what is the pH? Okay, multi-steps, think this through. Go. All right, did you get an answer? Hopefully you did, but if you didn't, that's okay. Don't freak out. The first thing you have to do is determine your H plus concentration. If you don't have your H plus concentration, you can't use your pH is equal to negative log equation. So the first thing I'm going to do is use this one that we've learned in previous videos, where we have H plus concentration times our hydroxide concentration. That's equal to 1 times 10 to the negative 14th. Now what I'm going to do is plug in my values so I can solve for my hydronium ion concentration. So now my hydroxide is 1 times 10 to the negative 4th molar, and we set that equal to 1 times 10 to the negative 14th. This probably sounds familiar for you because we did this previously. We found out that our H plus concentration is equal to 1 times 10 to the negative 10 molar. Now we have our H plus concentration. Now we can use our equation where we have pH is equal to negative log of our H plus concentration. All we have to do now is just plug it in. pH is equal to negative log of our 1 times 10 to the negative 10 molar, which we said before, if we just use this equation and there's just one little exponent right there, as long as that's 1, you can just grab that. So if you plug it into your calculator, you will see for sure that the pH of this solution is 10, which means we are definitely talking about a basic solution, all right? So you need to be able to use this one equation for both H plus and OH minus. So if I give you OH minus, you have to calculate your H plus concentration, then you can use the equation. But if I'm nice and I give you your H plus concentration right away, you can just plug it right into the equation. That's it. That's all I have for you. Have a great week. Take care of yourself. And remember that milk is not basic. Milk is not basic.